Hello friend, today in this video I am going to talk about the molecular shapes. This is very important to know the shape of the molecules. Lewis structure give atomic connectivity that tells us which atoms are physically connected to which. The shape of molecule is determined by its bond angles. Consider carbon tetrachloride. Experimentally we find all chlorine carbon Cl bond angles are 109.5 degree. Therefore, the molecules cannot be planar. All chlorine atoms are located at the vertices of the tetrahedron with the carbon and its center. So, friend, you can see the bond distances and angles. Now, molecular shape, the VSEPR theory, valence shell electron pair repulsion theory. So, if you see the AB2 molecules have two shapes, linear or bent. AB3 trigonal planar, trigonal pyramidal and T-shaped. So, there are 5 fundamental geometry for molecular shapes. You can see the linear, trigonal planar, tetrahedral, trigonal bipyramidal and octahedral. Now, when considering the geometry about the center atom, we consider all electrons, lone pairs plus bond pair. When naming the molecular geometry, we focus only on the position of the atom. So you can see tetrahedral converted into trigonal, pyramidal converted into bent. So to determine the shape of molecule, we distinguish between lone pairs, non-bonding pairs, those not in a bond of electrons, and bonding pair, those formed between the two atoms. So we define all electron domain geometry by the position in 3D space of all electron pair, bonding or non-bonding. Now you can see the number of electron domain, arrangement of electron domain geometry, predicted bonding is linear, trigonal planar, tetrahedral, trigonal bipyramidal, octahedral. So now you can see the ammonia, Lewis structure, electron domain geometry, tetrahedral, molecular geometry, trigonal, bipyramidal, and only pyramidal is not bipyramidal. So draw the Lewis structure for count the total number of electron pairs around the central atom, arrange the electron pair in one of the above geometry to minimize electron repulsion, and count multiple bond as one of the bending. Now you can see the linear, carbon dioxide, trigonal planar. You can see the tetrahedral. So tetrahedral, trigonal bipyramidal and bent. So we determine the electron pair geometry only looking at the electrons. We name the electron geometry by the position of the atoms. Remember. Now you can see the shape of ammonia, water and angles. 104, 107, 109. So you can see the bonding electron pair and nucleus, non-bonding pairs. So similarly, electrons in multiple bond repel more than electron in the single bond. So you have the examples like this. If you have trigonal bipyramidal, then you can see the PCl5, trigonal bipyramidal, SA4, very important, screw-saw, seesaw shape, and CAlF3, T-shaped, and XCF2 linear. Now octahedral, you have the square pyramidal, BRF5 example, XCF4 square planar. You see the different types of bond, axial bond and equatorial bond. This is the shape. Now in acetic acid, there are 3 central atoms. We assign the geometry about each central atom separately. You can see the carbon, and oxygens. So there is different electronegativity between the two atoms, then bond between them is polar. So you can see the overall dipole moment in carbon dioxide, 0. In water, the molecule is not linear and bond dipole moment do not cancel each other. Therefore, water is a polar molecule. You can see. So my friends, I hope this video will be helpful to you, and you can check here the polar, and non-polar molecules. Thanks for watching. If you like this type of video, then subscribe my channel, and thanks for watching.